A particle of mass 10 raised to minus 3 kg and charge 1 coulomb is initially at rest. At time t is equal to 0, the particle comes under the influence of an electric field E of t is equal to E0 sin omega t I cap, where E0 is equal to 1 Newton per coulomb and omega is equal to 10 raised to 3 radian per second. Consider the effect of only the electrical force on the particle, then the maximum speed in meter per second attained by the particle at subsequent times is. Okay, so in this question, there is a particle of mass is given as 10 raised to minus 3 kilograms and the charge is given as 1 coulomb. Okay, it is initially at rest, so the initial velocity is 0. Okay, at time t is equal to 0, it comes under the influence of an electric force. Yeah, electric field, and the electric field is given as E of t is equal to E0 sin omega t I cap. So because of some charge configuration, it is in the presence of an electric field, and whenever a charge is in the presence of an electric field, it experiences a force, and that force is given as F is equal to QE, right? So we have our force F is equal to QE, and because of the force, the particle gets accelerated. So you can write ma is equal to QE, or you can write acceleration is equal to QE divided by m. Okay, now we can write the acceleration as dv by dt. So we have to find the maximum velocity, right? The maximum velocity that the particle achieves. Okay, so first we have to find the relation between velocity with respect to time. So we have to find out at what velocity will be at what time. Okay, we have to find the velocity time relation. So we have to write dv by dt is equal to QE by m, or you can write dv is equal to QE divided by m into dt. Okay, now we can just integrate both sides of the equation, and it is said that at time t is equal to 0, the body is initially at rest, so both the limits will be 0 at the downside, and at time t is equal to t, the velocity will be v. Okay, so when we integrate integral dv, this will be v. Okay, so we can write v of t is equal to QE by m. Okay, so before that we have to find this electric field. This electric field is actually a function of time. Okay, electric field is actually a function of time. So before integrating this function, you have to substitute the value of electric field. So this will be integral 0 to t. Q and m are constant, you can take it outside, so this will be q by m into E0 sin omega t, okay, dt. So this will be q, E0 is a constant, you can take it outside, q E0 by m into integral of sin omega t. Integral of sin x will be minus cos x, so this will be minus cos omega t divided by omega, since derivative of omega t is omega, so you have to divide it by omega. Okay, with the limits 0 to t. So you can write this as q is 0 by m into, so there is a negative sign, so you can interchange the limits. You can take the omega outside, so this will be omega m into cos 0. Cos 0 is 1 minus, you can substitute for t here, so this will be cos omega t. Okay, so this is our value, final function of velocity. So we have got the velocity time relation, that is v of t is equal to q E0 divided by m omega into 1 minus cos omega t. Okay, so this is the relation. So we have to find the maximum velocity. So the maximum velocity is when this whole function is maximum. So q is a constant, E0 is a constant, m is a constant, omega is a constant. So this function is maximum when 1 minus cos omega t is maximum. Okay, so we know that cos omega t has can take the values of ranging between minus 1 to plus 1. Cos omega t can take values ranging from minus 1 to plus 1. Okay, including both minus 1 and plus 1. So if it takes the plus 1, our v of t will be 0. So that's the minimum value, And if you substitute for -1 instead of cos omega t, you will get 2 times the original value. So that's the maximum value this function can take. So the maximum value the function can take is when cos omega t is equal to -1. Then this minus and this -1 will become plus, and you will get twice this value. Okay, so this will be V max is equal to Q E0 divided by M omega. So this is the easiest way. You can otherwise find the value for which the function is maximum by differentiating. So that's a longer process. So just check like this. Okay, so this will be Q E0 divided by M omega into 1 minus of -1. So 1 plus 1 will be 2. So 2Q E0 divided by M omega. Just substitute for all the values here. So our Vmax will be 2 into what's the value of the charge? Charge is given as 1 coulomb, right? 1 coulomb into E0 I think it's given as 1 Newton per coulomb, right? 1 Newton per coulomb, yeah, into 1 divided by the mass is given as 10 raised to -3 into omega. What is omega? Omega is 10 raised to 3 radian per second. So into 10 raised to 3. So 10 raised to -3 and 10 raised to 3 gets cancelled. So this will be 2 meter per second. So the maximum velocity the particle achieves is 2 meter per second. Okay. So the maximum speed attained by the particle in subsequent times is 2 meters per second. Okay. So hope you understood this solution. Thank you.